Welcome to this presentation on FormZ Python scripting. Python is a powerful scripting language used to add custom functionality to many applications, and now, with FormZ 9, you can use Python to extend and enhance FormZ. We can't wait to see the new things that are going to be created with this exciting new interface. In this presentation, I will cover how to get started with Python for FormZ. We will cover installation and show how to create basic scripts, and we'll move into some more complicated scripts to look at how we might create the forms that you see on the screen here. All of the materials from today's presentation are available at formz.com/python, including sample scripts and documentation on the FormZ Python interface. This is a fluid interface, so we are constantly improving and adding new things, so always check back for changes. And if you have any features that you'd like to see in this interface, please let us know. Let's get started. Okay, so let's talk about why Python. So Python is much simpler to use than the old FormZ script language. It's also much easier to use than a number of the more restrictive languages, although they're more powerful. Things like C and C++, C#. These languages, while they generate faster code, they do so at the expense of a lot of very tight restrictions as far as typing variables and as far as being able to declare things and so on. So in that sense, it's much simpler to use. There's also a readily available set of Python libraries out in the wild, such as math libraries, geometry libraries, data mining libraries, connections to devices, you name it. There seems to be a Python library out there for almost everything. And with the FormZ connection to Python, now we can connect to those libraries. There's also a readily available supply of IDEs and utilities for Pythons. IDE being an integrated development environment, which gives you things such as code completion, syntax checking on your Python source files. So there's also a readily available collection of examples and tutorials on the internet on how to do almost anything with Python. So there's really a very large community of Python work out there. The other nice thing about Python is that it is interpreted. So there's not a lot of complex compiling, complex linking, all the type of things associated with some more of the more complicated programming languages. So, and Python for FormZ requires version 9 or later, and we're currently using Python 2.7. Now you may hear about Python 3, which is a newer version of Python, and we'll probably have support for that in the future. But there's such a wealth of material out there using Python 2.7 that that's what we've decided to use for now. So let's talk about how you install Python. So if you're using the Mac OS, you're lucky, you already have Python installed. Python 2.7 is installed on all Mac OS installations through Catalina. Now Catalina does have Python 3 installed, so you'll need to go to python.org and download Python 2. The current version is 2.7.16, I think, and you'll need to install that version for it to work with Catalina, and you'll also need to point your Python alias to point to the Python 2 instead of to Python 3. And you do that with a simple alias terminal command, and there's more details on how to do this on the Python website. Now if you're using Windows, Windows does not come with any Python installed in it, so you will need to install it if you don't already have it installed. And here again, you can install the latest 2.7 version from python.org. So let's get started. So source files or script files are just text files with a py extension, which stands for Python. So for example, myscript.py. Python files, the py files, are cross-platform compatible. You can create one on your Mac and take it to your Windows and vice versa. You can edit them with any text editor, or you can use a Python integrated development environment that is designed to work with Python files. So why do we not have a IDE for Python built into FormZ? Well, there's a lot of really good Python IDEs out there, so we decided it wasn't worth reproducing all of that work, and let's let them do what they do well, and we'll do what we do well. Now, a compiled Python script has a PYC extension. So even though Python itself is interpreted, when it is run on the local machine, it will be converted to a PYC file to be run. Now, PYC files are not cross-platform compatible, but you can run them on the platform that they were created, and you can share them with other people using that, which is a way to share things that you've created with Python without actually having to give out the Python source. So also, in order to run them in FormZ, your Python, your Py files, your PY files must be located in a directory with right permissions set, so that, because it'll actually generate that PYC file when it runs. So now we're going to talk a little bit about the Python language, and we'll show a lot of different examples in this presentation, but this is not meant to be an education course on Python. So to learn more about Python, you can reference the python.org site, specifically looking at the Python 2.7 reference. In general, Python is very easy to use in many ways, but there are a few things to watch out for. Particularly pay attention to indenting when you have a lot of statements such as ifs and whiles, because unlike other languages, Python uses indenting to determine what is the part of which statement. So, how do you connect Python to FormZ? Well, there's a module we've created called the FormZ Python interface, and it's a Python module that essentially connects the script to the FormZ functionality. This module comes along with the FormZ app, and it's installed with every FormZ 9 and later. There's nothing else that you need to add. But every script that is going to be used to access FormZ functionality must import this module. So the import statement is something that goes at the top of a Python script and tells the Python script what outside functionality are you trying to use, outside being beyond the scope of the Python source file that you're editing. So we need to import this into every FormZ script that you're going to use. Now, because the name FormZ Python interface is kind of long, we're going to import it typically as an alias with just FZ. This makes it a lot easier to read, but we have to distribute it with the longer name so that it doesn't collide with any other Python libraries that may be out there. So for example, in this case, we're importing under the name FZ, and hence every module function will be referenced with the fz.name, whatever function that we're referencing will be in that form. So the way that the flow of the FormZ Python interface is that some action inside of FormZ is going to trigger the execution of the script, and we'll talk a little bit about that in a minute, and then your Python script will be run, and you can make calls to things inside of FormZ to access data, to create objects, to do all kinds of things that you can do within FormZ, and you'll use this FormZ Python interface to actually do that. So let's take a look at a script. So a utility script is the most basic type of script. It's executed on demand. From the extensions menu, you just select Run Utility, and then you'll select your PY file or your PYC file. And boom, it's done. It runs. It does what it's supposed to do. If you've previously ever done a utility plugin with developing FormZ plugins, or if you've done a utility FSL, it's the same concept. It's just that these are on-demand scripts, and they're going to be run when the user selects that from the utility menu. Okay, so let's go ahead and dive in here and take a look at some code. What you've been waiting for, I know. Okay, so here is one of the most basic scripts. Here is a very simple script that's just going to create a cube. And I'm going to go very quickly through the parts of this script and make sure that everybody knows where we're starting from. So the first line you see is the import function that we saw before in the previous slide, telling Python that we want to use the FormZ Python interface. Okay, The next line is a function definition. So the word def in Python is a definition. In this case, we're declaring a function, and that function has to have the name fcmain with a capital M. And this is a function that FormZ is going to look for when it goes to execute a Python utility script, what we call a utility script. It's going to find that function, and that's the entry point. That's where everything is going to flow from. Now, I know if you've done some Python scripting before that this step may not be necessary, but in FormZ it is. So we make sure we're starting at a good starting point, and we make sure the script that we're using is designed to work with FormZ. Okay, the next line we see a call to one of the FormZ Python interface module functions. Here we're calling the cube function. And the cube function takes two parameters. It takes an origin and it takes a size. So in this case, we're passing in what would be called a tuple in Python. It's just a collection of numbers, and in this case, we know that a cube needs an x, y, and z value for its origin and an x, y, and z size for its dimensions. So that's what we see being passed in here. So let's jump over to FormZ and let's take a look at what this script looks like and what it might do. And this will give us a good chance to look at some of the basic workflow. So let's first take a look at the FormZ installation directory. Here's the FormZ app, and here is the scripts folder that comes along with FormZ. And if we scroll through here, we'll see you have a cube script. There it is, cube py. That's our Python script that makes a cube. We want to take a look at this script, so we need to open it, and there's lots of things that'll open Python files because they're just text files. For this example, we're just going to take a look at it with TextEdit. So I've opened it up with TextEdit, and here's the script, just a simple text file. Looks pretty much like what we just saw on the slide before. So we can now go over to FormZ and run that script. Let's see what it does. So I'm going to click in FormZ, go to my extensions, I'm going to select Run Utility, and now I'm going to navigate to that scripts folder. Here we are, FormZ9 Pro Scripts, and I'm selecting the cube Python file, and there we go. That's simple. It executed the script, and we get the cube that was created 5 units wide, 10 units deep, and 20 units high, just like we had set in the script. Go back to TextEdit, we can see there's our script. So, and the workflow from here is pretty fluid. So I can make a change to this file, save it, and then see the changes back in FormZ. So let's say we want to make another cube here. So I will make a copy of that line, and I'm going to say, instead of doing this cube at the same location, let's do the second cube, let's say 100 units over in X. So I'm going to make that to be 100. So now I simply save the file, and now I'm going to go back to FormZ. Now, here in FormZ, we see the cube that was generated with the previous iteration of the script. The entities that are created during the generation of a script are remembered by the undos. So I can simply now do an undo, to undo run utility. You see it'll say that there, and now that object is gone out of my project. I can go to my extensions manager, I can go select run utility, and go pick the file again, or I can select from the recent menu here, it'll show me the scripts that I've previously used, and there's my cube again, and now I can run it. Now, and let's run the script. Now I did something different with this on purpose to show you what happens if you make a mistake. Okay, on purpose, I overwrote part of the bracket that opens that sequence of numbers when I put my 100 in. Kind of easy to do if you're not careful, so this is what happens. I did this on purpose so you will see what happens when you do something wrong with a script. This is the feedback you get that something is wrong. Here it tells you that there's invalid syntax in your script. It's showing you the line and the file that the problem is, so you can go correct it. So it's telling you that there's a syntax on this line, problem with the syntax on this line. So I'm going to just hit cancel there, go back to TextEdit, and I can see right there that I overwrote the brace. that starts the sequence of numbers. So I need to put that back in. So I'm going to put that guy back in. I'm going to save it again. Now I'll go back to Form Z, once again run recent utility and run it again, and now you'll see I get the 2 cubes. So that's just kind of a demonstration of what happens if you don't have something correct in your script. Now, when you're using just a simple text editor like this, it doesn't know much about Python, and it didn't know that I had an improper sequence there. If you're using a Python IDE that knows about the Python language, it would actually warn you, usually on a line, on the same line that you have an error, and warn you that you have a problem. So that is the difference between using just a simple text editor and a IDE that knows the language and can give you more feedback. We'll look at one of those a little bit later. So, okay, let's go back and look at go back a little bit more and look at the script here. So this is our basic script, and it's oftentimes not convenient to pass these numbers in as tuples because oftentimes you'll want to use calculations to create numbers and be able to pass those values in as parameters. So how can we do that? Well, let's look at using types for our values rather than just using numbers. So here again, we're using a new function in Form Z called fz.xyz, and this is creating an xyz container to hold our Cartesian coordinate values. So here again, fz dot something is obviously calling into the Form Z Python interface, and in this case we're making a variable called origin that we're creating as an xyz type. Nice thing about Python here, we didn't have to declare what origin was. It's all interpreted, it's all implied from the values. Same thing here, we're going to declare one called size, and now we can then call our cube function by just simply saying cube, origin, and size. So that's pretty convenient and it can be really useful because maybe you want to do some other calculations to manipulate origin and size and then pass them in, which is much easier to use than those constant numbers. Okay. Now the next thing let's look at is what happens if you want to do something with that object once you've created it. So when the cube is created, it actually returns back to the script a reference to the object that it created. So in this case, I've now caught it in a container or variable, if you will, called my obj. So in my obj now is a reference to my cube. And I can now call a number of functions that exist on that class or type, and there's a whole suite of functions that are available which are methods of that object. So if, for example, I can simply say that I want to set the name of the object, and I can pass the string for the object name into that method, and now that object will have that name. So you have a class method, and then you'll have a set of parameters for those. Okay. Also, some functions, some methods, will take optional parameters. So that is that you don't have to give values for all the parameters for the function to do something meaningful. So for example, we're going to look now at the scale function. So in this case, I've created, again, a cube. I've caught it in the variable my obj, and now I want to scale it twice as big. Okay? Now, that's really all I wanted to do with this object, but the scale function itself also takes an origin that you could scale about. So if I provide an origin parameter, then it's going to use it and it's going to apply the scale about that value. If I don't give it that parameter, it's going to use a default value, in this case the Cartesian 0, 0, 0, the origin of the Cartesian system is where it will scale the object about, rather than scaling it about a specific point. So a number of functions will take optional parameters. These are all documented in the Form Z Python interface documentation, which we'll talk more about a little bit later. One other thing about optional parameters is that sometimes you may have a function that has a whole string of parameters to it, okay? And for example, we look at the torus function. The function to create a torus has a lot of additional information you could give it. It's required to give you the origin and the radius, the major and minor radius, but there's a lot of additional parameters that can go into a torus, such as capping options and partial tori and partial in both axes, and a lot of information that for the most part you don't always need. Okay, but let's say you wanted to set a specific value for one of those parameters, but you didn't want to have to list all the ones getting down to that point. Okay, in this case you can set optional parameters by name. So by giving the name of the variable and as giving it its value, you can assign it there, and you only have to give the ones that you want to set a value to, and there is not a specific order that is required for those parameters. They just need to have the right name and a valid value. And once again, you would refer to the FormZ Python interface to know what those are, and we'll talk more about that. We will talk more about that later. Okay, so let's look at some more code. Okay, so let's look at some more script examples. We're going to look at these. They're kind of going to be increasing in complexity. We're going to add some UI to one of them, and we're going to look at what we could do to use some built-in math functions and external libraries to do some more interesting things to generate some forms. So let's start with we'll start with our stair script. This guy is just a little, here again, just a variation of our cube that we did before. So let's I'm going to go to it's called steps. So let's just open the script again. For now I'm just going to open this with TextEdit just to look at it. All right. Here again, I don't want to get into a whole process of going through all the details of the Python language. There's lots of references for that, either books or online on the details of this. But just a basic description of this script is it's going to use our cube function again to create a series of steps. And in this case, we use what's called a for loop, which allows you to iterate through a set of values effectively. So once again, let's go back to FormZ, our run utility, and we're going to pick the steps from the list here, and there we go, there it is in the list. We'll just run that and you see what we get. I'll zoom in here a little bit. All right, so we created a series of steps where we changed the parameters. I'm gonna move this over a little bit here to the side so we can see them side by side. I'll bring up the TextEdit here so you can see it side by side. Going through the loop, we set up some basic parameters for the first step, and then we create a cube and we change the parameters as we go through the loop, building a new step each iteration of the loop at a new size and at a new dimension. And if you look over in the objects palette list here, you see the names of each of the steps, which coincide with the statement here where we've actually set the name towards the bottom of the script. So that once again, we're just trying to show you some examples of things that get a little bit more complicated, but still very simple and allow you to create some form. I think you can imagine how you can manipulate scripts like this to create some very interesting forms, and it doesn't take long to come very quickly to create lots of data and do some interesting things. Now, we're going to take one look at how you can make some of this data user controllable. I'm going to once again undo this, just like we did with the previous example, because we ran that. This was generated by utility, so let's undo that. Okay, so we just looked at some stairs. Now let's see what happens if we add some interface to that. So I'm going to run a utility that again builds stairs, but this time it has an interface along with it. So here are the stairs that we have, and you see this My Step Options palette came up. So what we've done is we've tied our script to a user interface. So I can, and this is live, so as I change the values, you'll see them changing in the live in the window. So here we go. I'm changing the number of steps. I'm changing the width of the stair, etc. So here I've created a dynamic script where I'm able to very easily change the parameters, and I see everything happens live as I do it. Okay, there we go. Live parameter changes happening then. So very simple script again, creating the steps very much like the way we did in the previous script. But now it has an interface to it, so you can really get some neat controls, and you can, obviously it's a very simple example, but I think you can see how this could be very useful. Let's take a quick look at how some of that's done. I don't want to get into all of the details of this script, but let's take a quick look at that file. It's this one, UI panel palette live Python. So once again, I'll open this one once more time with text editor. This will be the last one we look at. This we'll start looking at a little bit more complicated with an IDE just to get an idea of what that looks like. So here you see this script is a little bit more complicated, but not significantly so. Most of it's just adding the interface wrappers. And in our main script, here again, our FC main where things start, we create something called a panel, and that is the UI panel. And here again, this is a FormZ function that gets created. There you see the name MyStepOptions going in, and I've created this panel, and now we're adding things to it. Once again, these are functions of the panel, so we're adding sliders, we're adding checkboxes, radios, menus, etc. And when that's all built, we're telling it to present that to the user as a palette. You can present things as palettes, you can present them as modal dialogues, there's a number of different options that you can have. And then the way this works is it simply says present the palette, and when something changes, you're going to call this function, which is what we call a new value function, which means anytime a value in my interface changes, I want you to call this function for me. And if we look up a little higher, here is a function. We talked about it earlier. The def statement means you're defining a function. A function is just a collection of code, a collection of your script, part of your script. And so when one of those values, any of those values changes, it calls this function to re-execute the guts of the script, if you will. Now, the one part of it in this case too is we have to destroy what was created in the previous iteration of the script. So you see we keep an object list, which is all of the objects that were iterated in the previous version of the script. So that's what this is doing. This is deleting the objects and the memory for them. That's what you see the DEL statement here. That's actually deleting the memory for the container itself. So once again, don't want to get into too many details on the specifics of using Python. Those are things you can learn about on your own. But just wanted to show how you would tie this together. And essentially what happens is that here we're creating a slider. The first parameter is an identifier for each of those user interface items. So simply 1, 2, 3, 4, 5, they're in order in this case. And when we execute the new value function, we ask the panel to get the value. So tell me how many stairs they want this time. Tell me the bottom width. Tell me the top width. Tell me, am I reversing it? These are, again, all the parameters. We're just getting the value back from the interface panel so that we can generate it with those parameters. So that's very simple, easy to use, not a lot of complicated connections that have to be built and so on to connect your interface to your actual script that does the generation. So that's what this one does. And once again, there's more documentation on all these things as to what you can create and so on. Okay, so that's our user interface example. Now I think we'll move on to something that is maybe a little bit more geometrically interesting. We have some scripts to do some Mandelbrot forms, and let's take a look at those. So I'm going to look at the first one here. Let's just run this one. It's called MandelZ Grid, and so I'll go back to FormZ, and I'm going to open a new window just to clear out that previous thing that we had there. Close this guy. All right, and I'm going to go to the, now I did recently run this one, so it's already in my list, so I'm going to go ahead and select it from here, but it is in your scripts folder. And I'm going to select this guy, and he's going to run for a second. And what we have done now is created I'm going to change my view around. We have created an array of cubes that are all set their height based on this Mandelbrot fractal pattern. All right, which I think everybody is familiar with, has probably seen before. It's very recognizable, the form it takes on. And what we've done is we've used that algorithm to calculate separate heights. I'm gonna just do one thing to make this a little bit more readable due to the number of cubes that we have here. I'm going to turn off the silhouette edge display. It just makes it a little bit easier to see. And I can zoom in and you can see what's happening here. Okay. So here, again, we use just simply using the cube function that we had. We've used an algorithm to determine what height each grid, each cube should be based on its position in the image, based on, not image, but position in the fractal. And that has given us this form that we have created here. So there you can see all of that. So let's take a look at what that code looks like. And now for this example, I'm gonna open it with PyCharm. So PyCharm is, as I mentioned before, a IDE, meaning it's a development environment for developing Python. PyCharm actually supports a number of different languages, but primarily geared towards Python. So I've opened the script with Python, just with PyCharm. Again, just editing it as if I did the text editing. We're just editing the script. Nothing fancier than that, but what we do get from PyCharm is we get some nice formatting and we get some alignment of things, which makes it much easier to read the script. So something like PyCharm is a recommended addition if you're going to be doing a lot of Python development. There are a number of different ones that are out there. This just happens to be the one we choose to use. So. But right away you can see the function names get color coded. There's lots of things going on, and you can see some of the flow of the functions. Here we have some for loops. One of the things I mentioned before is making sure that you have things aligned properly, because if we did not have this for nested inside of the other one, if this was shifted over, it would function differently. So that's why I mentioned that that's something important to watch. And PyCharm is nice because it gives you these little guidelines that show you whether you have things lined up or not. So just to give you a quick overview of what this script does is that we've defined the height and width as how many boxes we want to create in each direction in our set, and the box dimension is the dimension of one box. Some other parameters include the domain of the fractal image that we're generating, so we can see different things. This is the basic Mandelbrot calculation, and we're using a complex math function to feed the Mandelbrot. So altogether, we're using the result of the Mandelbrot to calculate the height for our cube. And if the height is less than 0, then we went into what would be the void area of the fractal, and we actually don't generate a shape. So we don't generate a cube in that place. So here is the algorithm. Once again, we talked about how easy things are to edit and see different results. So we can actually, in here, we can make changes, and as we're developing things, maybe we want to do them at a lower resolution so that what we see is giving us faster results, and then we may bump it up higher when we're ready to see more of the results. So if I wanted to do that in this case, it iterates through the range based on the dimension of the box that we've asked for. So I'm using a box dimension of 2 and a width of 200, so we're getting 100 boxes in each direction right now. So just to show you the effect of making these changes, let's say, for example, we went to a box dimension of 10. So once again, I'm just changing this value. Okay, it's asking me, yes, I want to edit it. Okay, fine. That's just some idiosyncrasies of PyCharm because they would want you to build a project and work under that, which I'm just doing this example at the moment. So I'm going to say we change the box dimensions to 10 now instead of 2. So we're going to get bigger boxes. Once again, I'm going to save this. I'm going to go back to our back to Form Z, and I'm once again going to do the undo. And it takes a second, and then again I'll use the recent utility again, and we'll fire this guy. Now you see we get much lower resolution of our Mandelbrot, but much faster too. Okay, here again, just being able to work with the parameters and see things working and work back and forth between them are all things that are really useful in the workflow. So now, once you have these kind of things, it's very easy to start generating variants and so on. So, and that's what we've done here. We have, so I'm going to go, we have another version of this variant of this script that will generate things a little bit differently. So let me open that one. Actually, let's go over back to our directory, and I'm going to do one. Let's take a look at this here again. I'm going to open it with PyCharm again, just to, again, because as the script gets a little more complicated, it gets easier to read in these type of IDEs. So now my grid, the original one I had generated our grid here. You see where I'd set it to 10 as I had edited the file. So this one adds an additional level of iteration you can see here, and what it's actually doing is it's saving off, essentially saving off each layer of the iteration into its own z height. So it's kind of an interesting way to study what the algorithm is doing. So let's run that one and see what we get. I'm going to hide that for a second. I'm going to go back to Form Z. I'm going to go to my, I don't have it in my recent utility, so I'm going to go to Run Utility, and I'm going to go to my, this one is called MandelZ Grid Levels, and we'll let this run. I think the settings are currently set kind of high, but you'll see what the effect is. Okay, not too bad. And zoom out. What we've done is each level in height here is a higher order of iterations on the Mandelbrot algorithm. So okay, so there you see the shape, and here at the top level we've gotten quite a lot of, or we're getting a moire pattern from the grid lines there. You can see. I'm gonna zoom in a little so you see less of that, but there you see the fractals in here, the layers. Now as I zoom in there, you notice it's kind of hard to see those layers. So be nice if we had some colors in there to distinguish it. So I have yet another version of the script. So I'm going to undo that one, and I'm going to go look here. I have one called Level Colors. So once again, I'm going to open this with PyCharm again. And now I have 3 of them open, which is a nice thing in PyCharm because we can just look at the differences between them. And if I click between the 2 here, you see there's some additional step going on. And what we're doing is we're actually creating a material and setting a basic color on that material. Here we're using the hue we're setting based on the height of the iteration. And so now we can go back to Form Z, and we can run this version of the script, and you'll see the difference we get. So once again, let's go back here. I'm going to go to Run Utility. Let me get this guy up, And there we see the result of the script. Now each level of the iteration is a different color, so we can actually see a lot better what's going on here. And if we spin around, it's particularly more interesting. We zoom in and so on. So it gives you a much better idea of visually what the algorithm is doing. So it's just one more technique in evaluating and sharing and visualizing with this example. Let's see now. But one thing that we do notice with this example is that we end up with a lot of cubes that are the same height, which makes it pretty inefficient because we've got all these extra cubes that we don't really need. So wouldn't it be nice if there was a way to do these where all the cubes at the same height were combined together? And so we have another variation of the script. Let's go back to our to PyCharm here, and we can look at one that we call Mandel-Z quads. And in this case, it uses a little bit different technique in order to create the form by doing a subdivision until it gets down to a certain size. And in doing so, it's able to recognize that at different levels of the evaluation that the cubes all came out the same height, and it can in fact make a bigger cube representing what would otherwise be multiple individual cubes. So let's take a look at what this one is. This is just called Mandel-Z quads. So I'm going to go back to our project. I'm going to open a new project actually. Let's just do that. I'll go here to extensions, run recent utility. I have it in my list, so we can run that. And here it is. Now, it's running at a little bit lower resolution just to get a first look at it. So here you see that we get areas of the surface, of the form, rather, I should say, that are of the same height, form a single larger cube rather than having so many smaller cubes in those areas, which makes the model a lot more efficient. We end up with nearly half as many cubes in a higher level of iteration. So anyway, it just gives us some more control over it, gives us a better form, and then yet again, another variant here also we're including the coloring, so you can see the coloring based on the height instead of seeing it in individual levels as we did it in the previous example. We're doing it in the single level output we're generating with the script. So once again, we can see the effect that this script has as we make changes. So I'm going to undo that again. I'm going to go back to my back to PyCharm. Now here again, the algorithm works a little bit differently here. Here it evaluates until it gets below a certain width threshold, and it decides that that's where it should stop, rather than the previous example, we had a fixed iterative array that we were going through. So here we're going through really down until we hit some threshold. And so I just reduced the threshold from 10 to 2, resaving the file. I'll go back to Form Z. I'll go to my extensions, run recent utility, select the quads again. And it's going to run the process one more time. Now, obviously, this is the type of thing that you could also hook to some type of user interface, as we did with the previous step example. Okay, and there's the form that we get out of this. One thing I'm going to do, again, I'm going to go to my display options, and I'm going to turn off the silhouette edges just to make it a little bit cleaner to see, but you can see where at this iteration level, again, a lot of those individual cubes we don't see, but we only see it in areas where there is a variation in height, so that we have the resolution where we need it. Obviously generates a nice interesting form that we get now, and we can zoom in on this guy and we can see what's happening with our algorithm. Obviously we could keep changing those densities smaller and smaller, and we get more and more resolution in the areas of the Mandelbrot fractal algorithm. Obviously, turn off the edges entirely, then you get better view of the whole, more picturesque view of the whole form. And there you go. That's our Mandelbrot highly optimized example. Let's go. Sorry, I'm jumping around here. So resources. What resources are available to you to work on with the FormZ for Python interface? All the samples we just talked about. There are also, if you want to look and see how all of the stubs work, that all the functions work, there is a stubs file that's included in the installer, and you look at that file and you can see all the functions in there. There's also an HTML help file that will help you look at the function definitions with descriptions. Here again, these are all things that we're adding all the time. And let me, in all clearness here, we're still working on connecting more and more ports of FormZ to the Python script interface. There's literally thousands of things inside of FormZ, and every one of them has to be wired up to be accessible to the Python interface. So with each version, we are adding more things, and we'll have a section on our forum discussion dedicated to Python for FormZ, and we'll be posting updates to that when there are new things out there. There are many examples, as we said before, on how to do things with Python, different tutorials on using the Python language and doing generative forms and things with Python. So those are all things that would be relevant to FormZ for Python as well. And so where is this going? As we said, we're still publishing more and more connections between FormZ and the FormZ Python interface. So this will keep evolving as we go. New features will be available in there. Some existing features are not currently there, but we're working on adding them. If there's something that's very important to you, please let us know so we can prioritize it. But we will keep working on that all the time. We hope to have some exchange site where people can share some of the things that they've created. More news on that sometime in the future. Also, we're working on Python 3, as we mentioned before, being able to support that as well as Python 2 for the future. And something else that's being worked on is FormZ headless, which basically means that you could actually completely drive FormZ from a Python script if you wanted to, that the interface would never show. This will be really useful for using FormZ itself as a generative tool, and more on that coming up in the future. If you have any questions about Python interface, please send an email to devsupport@formz.com, and that covers our presentation for today. We just scratched the surface, but hopefully we've given you enough information that you can go code up something cool. Thanks.